Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you guys are doing good. In this, we're gonna see a problem, sliding puzzle. A quick thing. Tomorrow the problem would not be able to come. I have to go out, and that's very urgent. But I'll try to post something on like our community post. But yeah, like just a FYI for tomorrow. And again, in this problem, we are simply given a 2x3 board. The board size is fixed, and also there are 5 tiles with the labels of 1 to 5. As you can see, both sizes 2 cross 3, and there are 5 tiles with the value from 1 to 5, but there's one tile which is empty, which is actually represented by 0. Now the operation I can do is I can do a move operation. Move operation looks like that: choose a location having a 0 and then swap it with some adjacent number which is 4 directionally connected. So with this number 0, I will swap it with either this or this. And ultimately, my maqsad, my main aim is to able to achieve this specific board configuration, which is 1, 2, 3, 4, 5, 0. This is my ultimate maqsad. Now, given this given input board, you have to figure out how many minimum number, least number of moves are required so as to reach here. Cool. Now, obviously, that before even starting off, I will just give you a quick disclaimer. There is a very big hint that the board size is pretty small, and also you have to find out some number of moves. When the board size is pretty small, again, I'm not saying that what you should have tried all that stuff, but still, considering the constraints are pretty less, you should always try all the possible options which you can have, which means entirely recursion, or maybe all the possible options, all the possible combinations which you can have. Try it. Now for this example, we can simply see that we have this given input board. I will simply swap again, although for this 0 to swap, again, always swap the location where 0 is. For the 0 to swap, I can swap it with 2. It will become like this, swapping with 2. I can swap with 4. It will become like this. Or I swap with 5. It will become like this. Now, ultimately, in just one move, again, this is, I showed you all possible options for the first move. But I realized in the first move itself, I will be able to achieve my target. Thus, the minimum moves required are actually 1. Now, in the next example, although it's hard to draw here and show you that, okay, what are possible options you could have, but ultimately, just imagine that when you are trying for all the possible options, and I told you why you have to try for all the possible options, because obviously you can try for all the possible options. In that case, you figure out, okay, you cannot even go further to try on more options because now you are stagnant. In that case, have a -1. This will be clear with the next example. Next example says that you are given this 4, 1, 2, 5, 0, 3. Ultimately, maqsad is 4, 1, 2, 3, 4, 5, 0. Let's see how we achieve it. We have this 4, 1, 2, 5, 0, 3. Again, all the possible options. What if I swap with top? It will become a 0, 1. Or I swap with left, it became a 0, 5. Or I swap with right, it became a 3, 0. Okay, now again, for this also, we have not ultimately right now still able to achieve our 1, 2, 3, 4, 5, 0 configuration. Still try. Go on to the next move. Next move says, okay, if this is a 0, try for with its neighbors. Now, if I try with its neighbors, ultimately I can try. There is no harm of me trying. So I can swap my 1 and 0. But it will ultimately be same thing. 5, 4, 1, 2, 5, 0, 3. It is same way saying that I should unnecessarily not repeat my configurations. So I will have to maintain some kind of a visited array or visited data structure, which will tell what configuration has already been visited. Don't visit the configuration again. So in that case, you will see I only took the left swap and the right swap. That's it. I did not took the bottom one. Although I will take it, but then in the next iteration, it will be visited. So it will be ignored. So I ignored it right now only. Now, what if you, again, here you actually did this specific thing. So this is what you tried off. Again, for this specific thing, you could have tried off by swapping this or this. This is already ultimately done previously. So you will simply swap top. Same way in here, you can swap left or top, but left is already done. So I'll do only top. Okay, I did only top. Then the same in the next step here. For this, I can do a swap as right or down. Obviously, I will do down because right is already done. Here also, I can do swipe as left or down. Obviously, I'll do only down because left is done. Here also, I can do bottom or right. I will do right only because bottom is done. Here also, I can do a bottom or a right or a left. I will do a left because bottom is already done. Again, this will still go and try for the next move itself. Let me draw this only one which actually required. So here again you have two options. Either he can go left or down or right. Left is already done, so I will go simply right or I'll go simply down. Same way in the next iteration, in the next move, what I'll do, okay, this can go either left or down. Left is already done, so I'll simply go down. And thus, I was able to achieve a coefficient of 1, 2, 3, 4, 5, 0. And this was able to achieve in 5 moves. As if I just put it a bit of zoom out, move 1, move 2, move 3, move 4, move 5. Did you see what is happening here? You are trying level wise all the possibilities, although as I told you, recursion, which means you could also try DFS here and that will also work. But it seems more obvious to try more of a BFS approach. Okay, for one specific node, I'm trying for all the possibilities on its neighbor, and then from that node, all the possibilities again. That is how I am doing it. Again, as I told you, it's a simple graph traversal in which you are traversing all the possible options and ultimately keeping track of visited also, that you don't visit the same thing again and again. So both BFS and DFS will work, but considering how this is being shown and how I showed you as a level wise traversal, I will show you the same BFS code for it. Although more intuitive is BFS because the dry run itself actually showed you the BFS approach, and that's the exact same stuff. Now the thing is, okay, you got the approach, you got everything. How will you code it is actually question. You know it's a BFS, and in a simple BFS approach, you take a queue and you take a visited array. Queue, obviously you take it because you have to travel level wise. Visited you take so as to not visit the same thing again. And if you don't remember, in visited BFS traversal, we take a hash map or an unordered map so as to say, okay, this specific node, this specific thing is visited or not. But if you remember, in an unordered map, you cannot take argument as a key as an array. You can take here as an integer, as a boolean, as a double, as a string, but not an array, not a set. You cannot take an unordered maps argument key as a set or as a array or as another unordered map. So what to do in that case? We obviously try to figure out something. Again, one way is to use a map, simple map, but that incurs a complexity of log and factor also, which I might not be wanting. So what I could do is, one way is to rather use pointers. Take the specific array inside a place and point it via some pointer and use that pointer inside your hash map. That's one way, which is in the same way Java language using address. Or other thing is that convert this array, which is a 2D array for you, into a hash. If you remember, we usually have a technique of converting things to hash, but then usually people might start thinking, okay, Aryan, what should be hash? How are you thinking of a hash? Is it even required? It's pretty not hard, but a bit tricky to even think of and come up with a good hash. So again, that's not hard, but you could, if you choose a wrong hash, you could have a hash collision. That's unnecessary pain. The best is just take this input array, convert to a string. Simple. And how I will do it? I will take the input array 412503, convert to a string 412503. Awesome. Now, you simply converted it, and that's pretty easy. How to convert it? Simply iterate on your matrix from left to right, top to bottom, and keep on inserting the rows in your string. In your Java, it's a string builder. So now, okay, one thing is sorted. How I will actually use it. But the thing is that, okay, I know I will keep track of the string inside my visited hash map or a hash set, I should say. But still, there's one factor that now, considering you have done or converted to a string, earlier you were going 4 directionally adjacent cells, which is I minus 1 comma j, I minus 1 comma j, I plus 1 comma j, I comma j plus 1, I comma j minus 1, which was more of intuitive. But now it has a different indexes. Indexes are now like this 0, 1, 2, 3, 4, 5. Now you have to deal with this string and do swaps, kind of adjacent swap behavior on this string. Now I have plotted the same indexes onto this input array. As you can see, 0, 1, 2, 3, 4, 5. Now let's see that how this swap behavior would look like. Before even applying brains, I told you again, that's a very small constraint problem, hard code stuff, or try all the possible stuff, right? So I'll simply hard code it, which means at index 0, he can swap with index 1, index 3. Index 0, swap with index 1, index 3. At index 4, he can swap with index 1, 3, and 5. Index 4, 1, 3, and 5. Same way, at let's say index 2, he can swap with index 1 and 3. Sorry, 1 and 5. Simply make a hash map in which you will just keep a track of for this index. These are all the possible swap options. That's it. You are done. Now, ultimately, the code, it's exactly same as what we saw. Again, I will show you the corresponding Java code, but the similar code, you can actually get it in C++ also. Just I'll paste the link in the description and you can see from there itself. Now, code is pretty simple. Firstly, I made that specific hash map. Again, hash map, or simply you can take an array also, because index represent the key, right? So index 0, 1, 3, which means that for 0 as the position, I can swap it with index 1 or 3. For 1 as the position, I can swap it with 0, 2 and 4. That is how you can simply take your directions array or hash map you can take. So for simple terms, target string is 1, 2, 3, 4, 5, 0. Make sure मकसद नहीं बोलना है. Start state is, if as I showed you previously in this specific example, where 412503 is the start state. So 412503 is the start state. How will you get it? Simply iterate on your matrix and keep on inserting your corresponding values in the string. Again, I used simple collections in Java. I simply streamed onto my board, stream as an iterated onto my board, just converted to a actually int as a flat map, and then collected them as a string builder and converted it to a string and put as a string. Again, no worries, you can simply iterate it and put it in your string. That's completely fine. Now, as I know, it's a simple BFS, so I would be needing few stuff. What is that few stuff? Few stuff is nothing but visited array, visited set. Again, you can take hash map also, but a simple set will work. You can take a simple queue and then simply add that start state into the queue, make that start state as visited. Simply now move or keep on trying until you can go into the queue, which means until the queue becomes empty. How we do it? Simply we go level wise. When we say level wise, which means going on at each level. How will I do it? Get the current element. If the current is a target, if the current is the maqsad, then simply return the current number of moves you had right now. If not, then try to see the current 0 position, which is in the current string you have. What is the index of 0? Is the actual index of 0, which is the 0 position. If you have the corresponding 0 position, you now also know what is the corresponding next position, next possible 0 position, which you have to swap against. So I will find the next 0 position and I will do a swap. Unfortunately, in Java, there is no automatic swap functions which you can use. So you have to write your own swap function, but in C++ you have. So no worries. In Python also you have. So no worries. So here I'll just simply, this function is simply doing a swap in the string, add the syntax ing. That's it. I know it's worst part, but it is actually a worst part. So then when I have got the next state, I'll simply check if it is already visited, don't visit it again, else you will go into an infinite loop TLE. If not, then simply visit it and also put that in your queue. Ultimately, make sure that considering you have gone on to one level, increase your move count because you are now going to the next possible level. Ultimately, even after trying and getting the queue empty, you are still not able to return from here, which means you never was able to achieve your answer. And that's what the case, what I was mentioning was that in this case, you will ultimately get -1 when you are not able to even achieve anything. So in that case, answer is -1. Now, the best part, what is the time complexity for this? As I told you previously also, you're trying for all the possibilities. What I mean by all the possibilities? Simple permutation and combination, which means that for this input matrix, imagine it is empty. For every cell, I have 6 options. For the first cell, I have 6 options to place numbers here. 6, 5, 4, 3, 2, 1. 6 options. Next cell, I have 5 options to place. Next cell, 4 options to place. Next cell, 3 options. Next cell, 2 options. Next cell, 1 option. Thus, 6 into 5 into 4 into 3 into 2 into 1 is 6 factorial. In other terms, I can also put it as m into n factorial because again, m and n are constant, which is 2 into 3. Thus, you will be good to go in that terms. But even if you take that all possible combinations for this entire matrix, which you had for 2 cross 3, still there's one thing because you are now iterating on the string. The string itself represents current one state. And to check if this is already there or not, so you have to compare 2 strings of length 6. Thus, this is the add-on complexity of m into n for each corresponding combination. Now, this is time. What is the cause? Again, this is pretty less. So you are good in that terms. Again, I don't know why I'm saying good in that terms again, but yeah, that's the pretty much crux for it. Now, for the space itself, you know that because visited can store all possible combinations in worst case, again, all possible combinations are itself O of 6 factorial, which is nothing but O of m into n factorial. I hope you guys got it. If yes, then do smash the like button, and probably tomorrow, yeah, I won't be able to comment, but yeah, Wednesday we'll be coming back. Bye bye, take care, and do follow us on Twitter and LinkedIn, and again Discord and Telegram for doubts, communications, regular stuff. Bye bye, take care.